Look up at the night sky tonight, at all those stars, the moon, the faint smear of the galaxy. Now here is something that should genuinely rearrange how you see all of it. Almost everything you can see up there. Every star, every planet, every glowing cloud of gas, and for that matter, your own body and this screen, adds up to a small minority of what is actually out there. The overwhelming majority of the matter in the universe is completely invisible. We cannot see it, we have never directly detected it, and we still, to this day, do not know what it is. We only know it has to be there because of its gravity. Roughly 85% of all the matter in existence is this unseen stuff. You are made of the rare, glowing exception. And the man who first figured this out, who looked at the cosmos and realized most of it was missing, did it back in 1933, decades before anyone else. For his trouble, he was dismissed, ridiculed, and largely ignored by colleagues he himself liked to call, and I am quoting him, spherical bastards. His name was Fritz Zwicky, and he is one of the most maddening figures in the history of science because he was right about almost everything, decades early, and almost no one would listen. He didn't just discover the evidence for what we now call dark matter, he also predicted the existence of neutron stars, some of the strangest objects in the cosmos. He predicted that galaxies could bend light like giant lenses. He coined the word supernova, idea after idea after idea, all confirmed, most of them decades after he proposed them, and several of them credited at first to other people. Now, I'm going to be honest with you, because the truth here is more interesting than a simple tale of a misunderstood genius. Part of why Zwicky was ignored is that the science was genuinely hard to prove with the tools of his time, and part of it, frankly, is that he was a difficult, abrasive man who insulted the very colleagues he needed. So let me show you the universe he saw that nobody else could, why they refused to believe him, and how being right too early and too loudly can get you written out of your own discovery. Fritz Zwicky was by every account brilliant and impossible in roughly equal measure. He was born in 1898, Swiss by heritage, and he ended up at Caltech, working at some of the greatest observatories in the world. And he had a mind that fired off bold ideas in every direction, faster than the cautious, careful field around him could absorb. He also had no patience for that field, and he let everyone know it. He dismissed huge swaths of published astronomy as worthless. He feuded openly with his colleagues, including the people he collaborated with. That famous insult, calling his fellow astronomers spherical bastards, he explained with relish, meant they were bastards no matter which way you looked at them. Now, picture the situation that creates. Here is a man with genuinely revolutionary ideas, who also happens to go out of his way to offend the exact people whose support he would need to get those ideas accepted. It is a tragedy, partly of his own making. But set the personality aside for a moment, because what he actually saw, when he pointed his attention at a distant swarm of galaxies, was the truth. In 1933, Zwicky was studying something called the Coma Cluster, an enormous swarm of more than 1,000 galaxies, all bound together by gravity, drifting through space as a group. And he set out to do something clever. He measured how fast the individual galaxies in the cluster were moving relative to one another. This matters, so stay with me, because the logic is beautiful, and you can follow all of it. There is a well-understood relationship in physics. For a group of objects held together by gravity, how fast they move tells you how much mass must be holding them. The faster they whirl around, the more gravity, and therefore more mass, you need to keep them from flying apart. It's the same principle as a sling. Spin it slowly, and a gentle grip holds the stone. Spin it fast, and you need to grip much harder, or the stone tears free. Zwicky measured how fast the galaxies were whirling. Then he added up all the mass he could actually see, all the stars and glowing gas. And the two numbers did not even come close to matching. Here's what Zwicky found, and why it stopped him cold. The galaxies in that cluster were moving so fast that the visible matter, everything that gives off light, came nowhere near providing enough gravity to hold them together. By all rights, the cluster should have torn itself apart and scattered long ago. The stars he could see were like a tiny grip trying to hold a stone that was spinning far too fast. So picture a merry-go-round spinning so violently that the riders should be flung right off into the air, but they aren't. They're staying on, perfectly held. What would you conclude? You'd conclude there must be some powerful, invisible force, some unseen weight, gripping them that you simply cannot see. That is exactly the conclusion Zwicky reached about the galaxies. There had to be a vast amount of matter in that cluster that gave off no light at all, providing the extra gravity to hold the whole thing together. He called it, in German, Dunkle Materie, dark matter. Let that sink in, because of what it really meant. Zwicky wasn't saying he'd found a new planet, or a dim star he'd missed. He was saying that most of the matter in that entire cluster of galaxies was a kind of stuff nobody had ever seen, that emitted no light, that announced itself only through the pull of its gravity. The visible universe, the part we'd been studying and mapping and marveling at for all of human history, was just the surface. Underneath it, around it, holding it together was a hidden cosmos, far larger, made of something else. Now I have to be careful and fair with you here, because of two things. First, Zwicky's original numbers were way off. He estimated there was vastly more dark matter than we now think, mostly because he was using a badly wrong value for the size and scale of the universe, a standard error of his era, so his specific figure was inflated. But, and this is the crucial part, his conclusion was right. Correct the error, and a huge amount of missing invisible mass is still there in that cluster. He had the wrong number and the right universe. And dark matter was only the beginning of how far ahead of everyone Zwicky was. Around the same time, working with a colleague named Walter Baade, he turned his attention to the most violent events in the cosmos, the deaths of massive stars. The two of them coined the term you still hear today, supernova, for a star that detonates in a burst so bright it can briefly outshine an entire galaxy. But they went further, into territory that sounded like pure fantasy. They proposed that when such a star collapses and explodes, it can leave behind something almost impossible to imagine. An object so dense that all its matter is crushed down into a ball of packed neutrons, a city-sized star weighing more than our sun, a neutron star. Remember, this was the early 1930s, barely after the neutron itself had even been discovered. They were describing an object that wouldn't actually be confirmed to exist for more than 30 years. It sounded absurd. It was completely correct. Then, in 1937, Zwicky did it again. He took an idea that flowed out of Einstein's theory of gravity, that mass bends the path of light, and he saw a use for it that others had dismissed as impractical. He realized that an entire galaxy, with its enormous mass, could act like a giant lens in space. The light from a more distant galaxy behind it would get bent and magnified as it passed, sometimes smeared into arcs, sometimes split into multiple images. Gravitational lensing, we call it now. And here is the thing that should make you shake your head. Zwicky proposed it in 1937. The first real example of a galaxy lensing the light of a more distant object was not actually observed until 1979, 5 years after he had died. He never got to see it confirmed. And today, that very effect, the light bending he predicted, is one of the main tools astronomers use to map exactly where the invisible dark matter is. The thing he predicted is now used to study the other thing he predicted. He was that far ahead. So you have a man who, in a span of just a few years in the 1930s, correctly identified dark matter, predicted neutron stars, and predicted gravitational lensing. You would expect him to be one of the most celebrated scientists of the century. Instead, his ideas mostly sat there, ignored. His 1933 dark matter paper, one of the most important results in the history of astronomy, was barely cited by anyone for something like 40 years. The field just wasn't ready. The data was hard, and let's be honest, the messenger had made himself easy to dismiss. And here's the part that genuinely stings. When dark matter finally did become mainstream, when the astronomy world finally accepted that most of the universe is unseen, the breakthrough that convinced everyone came from someone else. In the 1970s, an astronomer named Vera Rubin, working with Kent Ford, made careful measurements of how stars move within individual galaxies, and found the same impossible thing. The stars at the edges were moving far too fast for the visible matter to hold them. Her work was so clear and so thorough that it finally forced the issue. Now I want to be careful and fair, because it would be easy and wrong to turn this into Vera Rubin stealing Zwicky's discovery. She didn't. Rubin did her own brilliant, rigorous work, and she absolutely deserves enormous credit for making the case for dark matter undeniable. The honest version is this. Zwicky saw it first, in 1933, in the motion of galaxies in a cluster, and was ignored. Rubin, decades later, saw it again from a completely different angle, in the motion of stars within galaxies, and this time, the world listened. Both of them deserve to be remembered, and for a long time, neither got their full due. Rubin, despite work that transformed our picture of the universe, was famously never awarded the Nobel Prize. And Zwicky, the man who got there first, spent decades watching the field slowly, grudgingly catch up to things he'd said in the 1930s, often without much credit at all. The universe proved him right. His colleagues took their time. But proven right he was, completely, on essentially every count. Neutron stars, the impossible crushed objects he and Baade dreamed up, confirmed in 1967, when astronomers discovered pulsars, which turned out to be exactly that, spinning neutron stars, sweeping beams of radiation across the cosmos. Gravitational lensing, the light bending he proposed in 1937, confirmed in 1979, and now a workhorse of modern astronomy. And dark matter, his strangest and most important claim? It is now one of the central pillars of our entire understanding of the universe. We can put numbers to it that Zwicky never could. Of all the matter in the cosmos, only about 15% is the ordinary kind, the stuff of stars and planets and people. The other 85% is dark matter. And if you widen the lens to count all the energy in the universe, the ordinary visible stuff drops to around 5% of everything, with dark matter at roughly a quarter, and an even stranger thing called dark energy making up the rest. The Cosmos Wiki, glimpsed in one galaxy cluster, turned out to be the whole story. And yet, here is the humbling truth that keeps Zwicky's discovery alive and urgent right now, almost a century later. We still do not know what dark matter actually is. Think about that. We know it's there. We can measure how much of it there is. We can map where it sits in the sky, using the very lensing effect he predicted. We know it outweighs everything we can see by more than 5 to 1. And we have absolutely no idea what it's made of. It is not stars, not gas, not planets, not any ordinary matter. Physicists have spent decades building detectors deep underground and smashing particles together, hunting for it, and so far it has refused to show itself as anything but gravity. So when Zwicky pointed at that cluster of galaxies in 1933 and said, in effect, most of this is something we cannot see, he didn't just make a discovery that took the world 40 years to accept. He opened a mystery that to this day remains one of the biggest unanswered questions in all of science. So go back outside on the next clear night and look up again. Only now you know the secret hiding in that view. Everything your eyes can take in, every pinprick of light, the whole glittering sky that has awed every human who ever lived, is the thin, bright skin on top of a vast invisible ocean. Most of what is actually out there gives off no light at all, and it is woven through everything, holding the galaxies together, bending the starlight on its way to your eye. You are standing on a small rock, made of the rare glowing 5%, gazing out at a universe that is mostly a question mark. And one difficult, brilliant, deeply unpopular man saw all of that first, in 1933, and was told he was wrong, or ignored, or simply not believed for most of his life. The universe he described is the one we now know we live in. So the next time someone shows you a beautiful picture of a galaxy and calls it the cosmos, you can tell them the truth. That's just the part that glows. The rest, the most of it, is Fritz Zwicky's dark matter, still waiting for someone to finally say what it is. If Fritz's story got under your skin, do me a small favor. Like this video? Subscribe to follow the rest of these. And tell me in the comments whose forgotten story I should draw next. There are so many of them still waiting for someone to finally know their name.